Hello class, in this video we're going to learn about least squares regression lines. The line of best fit, regression line, or the least squares regression line are all terms that relate to drawing a straight line that runs through the scatter plot in an attempt to illustrate the linear trend or the linear relationship between two variables. Out of these three terms, you should already know what the line of best fit is and know how to roughly draw one. Please recall that when we do draw our line of best fit, this is a very cute hand-drawn attempt at trying to therefore find the average trend line that runs through the actual dataset. And because it's subjective, this means that everyone's line of best fit, as well as their equation, will vary from one another. It is due to this nature that this particular approach, where we draw the line of best fit by hand, is therefore inaccurate and therefore not very useful when we're trying to make predictions using our equation for the line of best fit. Let me show you an example to demonstrate what I mean by this. So let's just say that we were trying to plot our scatter plot and a line of best fit for this particular data set. This is what our scatter plot would look like if you were to draw age versus height. And if you were to draw the line of best fit, my line of best fit may look like this, but you may draw it in another way. You might have drawn it like this, or another person may have drawn it like this. And as you can see in each of these three examples, notice that like the slope is slightly different and the positioning is slightly different as well. And because of this, everyone's equation will be different. Since this by hand approach is inconsistent and not accurate, we could use the CAS calculator to generate the line and equation. When we use the CAS calculator to help draw the line of best fit, we refer to this line as the least squares regression line, or regression line for short. There are two methods or two approaches you could use for us to obtain our equation. One of the methods that you could use is by following the same steps that you did to find out Pearson's correlation coefficient. In doing so, this will tell you both the equation as well as the correlation coefficient. However, using this method won't show you the actual graph whatsoever. In contrast, the second method involves constructing both a scatter plot as well as the linear regression line so that you can visualize the dataset and also see the equation. The only limitation with this method is that it won't tell you the correlation coefficient, so you would therefore need to resort to the first method if the question also asks you to find this. I would like to add that in your final answer for your equation, you shouldn't contain any letters such as x and y in your general equation. Instead, you should be substituting the variables in. So if it's talking about carbon dioxide emissions and income, you should use those words rather than y and x. Let me show you an example so I can illustrate what I mean by this. So I'm going to show you both methods using this particular example which we looked at previously, but this time we're going to find out what is the equation. So using the first method, what we're going to do is we're going to follow the exact same steps as we did previously to find out Pearson's correlation coefficient. So this involved creating a spreadsheet and putting all the values in each respective column. And what we're going to do is click on the calculator, stat calculations, linear regressions, put in the explanatory variable for your x values and put in the response variable for your y values. And if you do that, this is what you should be getting. Please recall that the general formula for our regression line is in the form of y equals a plus bx. So all we simply need to do is substitute the values of a and b into this general formula. However, please keep in mind that we do need to correct to three significant figures. So if we look at a, the first three significant values is going to be 1, 3, and 8. However, because the fourth value is larger than 5, then we're going to need to round up 8 to another number. So therefore, it's going to be 1.39. And we need to do the same thing for the value of b. So the first three significant values are 4, 1, 6. But similarly, because the fourth value is 5 or higher, we need to therefore round up the last digit. So therefore, it becomes 0.417. And I'm going to plug in these values for values a and b. And hence, this is going to be my equation. However, as I stated earlier on, our final equation should not contain the letters x and y, and we should replace these letters by the variables that are given in the question. So what I'm going to do is I'm going to replace income with x, because that's for our explanatory variable, and CO2 for y, okay, because that was our response variable. So therefore, our final equation should look like this. This time, I'm going to show you how to get to the exact same answer using the other method. So in this particular method over here, again, you still need to create this spreadsheet and put down all the values into the spreadsheet. And after you've done that, this time you're going to need to graph it. So we're going to click on this graphing button here, put your explanatory variable under the x-axis, the response variable for your y-axis, then click Menu, Analyze, Regressions, and then make sure you choose the a plus bx, and therefore this will give you both the scatter plot, the regression line, as well as its equation. Again, you just need to correct it to 3 significant figures, and if you do so, you'll still arrive to the exact same answer. What I'd like you to do now is I want you to have a go at using either one of these methods to find the equation for this particular problem. Just a reminder that you should try to identify what is your explanatory variable and what is your response variable for this particular example. In this particular question, there are 2 variables, hours studied and our test results. It makes sense that the hours studied will positively impact our test results, which is why our hours studied is going to be the explanatory variable and test results is going to be the response variable. It is important that you get this step correct, otherwise your equation is going to be incorrect. So what I'm going to do next is create a spreadsheet and put down all the values for each of my variables. And then after I've done that, I'm going to go back to the calculator, go onto statistics, stat calculations, make sure you put your explanatory variable for your x-axis and your response variable for your y-axis. All I need to do now is to round the values of a and b to 3 significant values and then plug them back into the general formula. So if I do that, this is going to be my final answer if I also replace the letters y and x by the appropriate variables. If you've done this using the second method, then what you would have done is you would have had to create your scatter plot as well as your regression line, and in doing so, you'll still arrive to the exact same answer as you can see over here. What I'd like you to do now is to please answer all questions from exercise 7F to get further practice. As you can see by these questions, they do also ask you to find out what is Pearson's correlation coefficient, so I'll probably recommend using the first method to answer all of these questions over here. This is the end of the video. Thank you guys for watching, and I'll see you guys again in the next one. Bye.